This is the post-project world. I'm Luigi Pascal Rondanini. Today I want to talk about a problem that every regulated institution has and almost none of them can see clearly. Business logic is scattered. Let me describe what I mean. A financial institution has a high-value payment threshold. When a payment exceeds that threshold, a specific approval tier is required. When the payment involves a blocked jurisdiction, the action is denial, not escalation. That policy exists somewhere, usually in a Word document approved by a committee, probably in 2019. Now look at what happened next. 3 systems implement that policy: Python in one team, Java in another, a COBOL batch job on the mainframe that nobody wants to touch. Each implementation was built independently. Each drifted slightly from the original intent. Each uses different variable names, different thresholds, different edge case handling. When audit asks which line of code enforced that limit on the 15th of March, the room goes quiet. Not because people are hiding something, because nobody can trace from policy to code to execution with certainty. That gap between what the institution says its rules are and what its systems actually enforce is a governance failure, and it exists in every institution I've worked with. This is the problem OrbaLang addresses. OrbaLang is a transpilation-first business logic language. Let me unpack that in plain terms. You write business rules once, in a small, readable syntax that a compliance officer and the developer can both read. You validate them, then you emit them to Python, to TypeScript, to Java, to Go, to SQL, to COBOL, to whatever stack your teams already operate. Not a proprietary runtime, not a central rule server, source code that your teams deploy wherever they already work, the same rule, the same logic, the same audit trail, across every target. OrbaLang is part of the OrbaOS program. In the doctrine, I describe OrbaOS as governance formalization, the structural expression of how coordination capital governance persists as architecture. OrbaLang occupies a specific layer within that architecture. It makes the flow layer explicit. When a condition holds, what must happen and why, written so an operator can read it and an auditor can follow it. Let me be clear about what OrbaLang is not. It is not a general-purpose programming language. You will not build a web application in OrbaLang. You will not loop forever, import libraries, or call external services through a backdoor. That is deliberate. Every construct must map cleanly onto mainstream languages and legacy emitters. If it is hard to transpile everywhere, it does not belong. It is not a rules engine. There is no central inference loop running in a vendor cloud. OrbaLang is transpile first. The rule is the source of truth. The outputs are validators and functions in your stack. It is not a low-code screen where policy lives only in a database. The policy is text. It lives in version control. It is diffed in pull requests. It writes the same pipeline as your other code. So what is it? Each OrbaLang file is one of 2 things. Either a function, typed inputs, deterministic steps, a typed return, calculate a tax amount, apply a discount, compute a shipping surcharge, functions, answer the question, what is the value? Or a rule, typed inputs, a Boolean condition, a required governance action when that condition is true, plus audit metadata. Rules answer a different question, what must we do, and under what control? That distinction matters. In regulated environments, payments, treasury, sanctions, approvals, the second question is the one that keeps people employed and keeps regulators satisfied. Let me walk you through a rule, the way OrbaLang wants you to think about it. A high-value payment. When the amount exceeds the threshold, the organization requires a specific approval tier. The when clause is the condition. The then clause is not a free-form script. It is governance vocabulary. Approve, deny, escalate. The audit block records who owns the policy, why it exists, and which program it serves. That is the governance chain: input, condition, action, rationale. OrbaLang is biased toward that chain being short and visible. Now compare that to the status quo. The policy in a Word document. 3 implementations that drift over quarters. No traceability from intent to execution. When something goes wrong, and things do go wrong, nobody can produce the chain. OrbaLang does not magically fix organizational politics. It gives you one place to write the intent and many places to emit consistent behavior. Let me explain the transpilation architecture, because it is the reason this works. Under the hood, the compiler builds what I call semantic IR, the canonical internal representation of meaning. Functions and rules share one stable schema. Transpilers consume semantic IR, not raw syntax. That is why adding a new target is feasible. That is why outputs stay consistent across Python, TypeScript, Java, COBOL, and everything else. If you are technical, think of semantic IR as the contract between what you wrote and what gets emitted. If you are not technical, think of it as the notarized version of what the rule means, independent of which language it is expressed in. This is infrastructure for logic. The same way the doctrine treats coordination as measurable capital, OrbaLang treats business logic as a portable, governed artifact. Let me apply this to a treasury desk, because that is where I've lived for most of my career, and it is where the problem is most visible. You have a daily limit, you have a high-risk escalation path, you have invoice approval thresholds, you have blocked jurisdictions. Each of those is a candidate for a rule file or a function file. The function files compute the numbers you need, deterministically, once. The rule files encode the must and the why. You emit Python for the team building microservices, you emit TypeScript for the web tier, you emit COBOL because the settlement engine still lives there, and pretending otherwise is how incidents happen. The same when clause, the same then action, the same audit block, not 3 interpretations that drift over quarters. That is the promise, not magic, discipline. Let me address the comparison you will hear in procurement, because any new tool gets benchmarked against the existing landscape. Drules and its peers give you a runtime and often a vendor dependency. OrbaLang gives you source code and emitters. Your runtime is yours. OPA gives you policy as data and a powerful evaluation engine. OrbaLang gives you policy as auditable language with multi-target code generation, including legacy validators that some programs still require. DMN is excellent for decision tables. OrbaLang is adding decision table syntax, but the deeper proposition is one language for functions and rules, one canonical representation, one conformance story across modern and mainframe. Python alone is infinitely flexible, which is the problem. Flexibility without governance vocabulary becomes 10 styles in 10 repositories. OrbaLang is narrow on purpose. The win is not winning a benchmark. The win is a compliance officer and a developer reading the same file and meaning the same thing. Audit metadata deserves attention because it is what separates a business logic language from a governance logic language. Every production OrbaLang rule can carry author, version, and reason. Program-level attribution connects to OrbaOS and the coordination capital doctrine. Local ownership stays in owner fields on individual rules. The language does not replace your governance forum. It gives the forum something concrete to attach to. When something goes wrong, you want a chain: input, condition, action, rationale, owner, version. That chain should be short, traceable, and visible. OrbaLang is designed to make it so. Let me connect this back to the doctrine. In Chapter 15, I describe OrbaOS as governance formalization, the structural expression that binds measurement discipline, authority routing, and evidence custody into a continuous governance system. OrbaOS is not a tool. It is the architecture through which coordination, capital governance, becomes a property of the institution rather than a practice of individuals. OrbaLang serves that architecture at the logic layer. The coordination capital ratio tells you how much coordination exists and what it costs. The structural floor tells you how much is mandatory. Classification tells you what type each allocation is. OrbaLang tells you what the rules actually say in every system, in one language, with one audit trail. Measurement without enforceable logic is observation. Logic without measurement is assertion. Together, they create a governance system that can explain itself. Let me describe who should care. If you are a CFO and your institution cannot trace from board-approved policy to the line of code that enforces it, this is relevant. Not because you need to understand the syntax, because you need the traceability chain to exist. If you are an audit committee chair and your control testing relies on screenshots of a user interface that nobody can replay, this is relevant. OrbaLang rules are testable, versionable, and diffable. The evidence is the source, not a screenshot. If you are a risk officer and your institution operates between modern APIs and a mainframe that still clears half the desk, this is relevant. OrbaLang emits to both. The same rule, the same logic. No translation gap. If you need a general-purpose language or a rules dashboard with no export, this is not your tool. OrbaLang is MIT licensed. The language lives in the open. A playground is available at lang.orbaos.com. The doctrine and trademark live under Rondanini Publishing. It sits within the OrbaOS ecosystem alongside OrbaOS instruments, Scenario Forge, and the coordination capital doctrine itself. Different products, same architecture. Coordination, capital, and logic as things you measure and deploy, not things you argue about in a standing meeting. I want to leave you with one idea. Every institution has rules. Most institutions cannot prove that their systems enforce those rules consistently. That gap is not a technology problem, it is a governance problem, and governance problems require governance solutions. Write rules once, emit them everywhere, trace the chain. This is the post-project world. I'm Luigi Rondanini. Thank you for listening.